Bismillahirrahmanirrahim. This is Umar Farooq from MSEE. Today, the topic of my presentation is AGSM MIMO system for wireless communication. In this presentation, I will talk about the MIMO system, then the difference between conventional MIMO and single RF MIMO. Then we will talk about the spectral efficiency of SM MIMO, GSM MIMO, ESM MIMO, and then AGSM MIMO. In the last phase of this lecture, I will talk about the proposed scheme of AGSM MIMO. So, what is MIMO system? MIMO system is a system having many input and many outputs in the communication system. It having many advantages like high data rate, good quality of service, and multiple streams of data. Generally, a MIMO system consists of a transmitted vector, a channel matrix X, and a received vector. The feature of MIMO system is spatial multiplexing, or it increases the data rate due to the many antennas at the transmitter and receiver system. As the MIMO system is spectral efficient, that is, it having high data rate, high transfer of data rate, but it is not efficient in the energy level. That is, it requires more power for the thickness of antennas at the transmitter as well as at the receiver station. So, in the wireless communication, in the wireless communication, we have to compromise between spectral efficiency and energy efficiency as well. If we look at this diagram, the conventional MIMO having multiple radio frequency chain at the transmitter side, while in the single RF MIMO or spatial modulation MIMO, SM MIMO, we have a single radio frequency channel at the frequency side. In the SM MIMO, we have many number of antennas active at the receiver as well as at the transmitter side. So, if we see, in the SM MIMO, we have number of active antennas in the transmitter and receiver side as well. If we want to reduce the energy efficiency, we have to turn off some of the antennas at the receiver or at the transmitter side. In this case, we introduce a new system which is known as GSM MIMO, generalized spatial modulation. The SM MIMO having number of active antennas is equal to the power of 2, while in GSM MIMO we have number of active antennas log 2 into number of transmitting antennas. In order to face this problem of energy efficiency and spectral efficiency, we introduce a new system which is known as AGSM MIMO. In AGSM MIMO, the energy efficiency and spectral efficiency both are good as compared to the ASM, GSM and ESM MIMO. Here is the simple block diagram of the AGSM model. It is a transmitter side, then there is a channel matrix, and there is a receiver model. The dotted line shows the feedback signal for the better channel condition. If the channel condition is better, then the number of active antennas becomes high and data rate or the quality of service becomes better. If we look at this simulation graph, it is the graph between multiple 4 QAM, 8 QAM and 16 QAM model, GSM model, and the green dotted line shows the AGSM model, which clearly shows that the SNR to BER ratio is much better than the GSM MIMO. Similarly, if we compare the AGSM model between multiple antennas, active transmitter and receiver side, we can clearly see that if the number of antennas increases, the ABR rate will be better. Similarly, in this graph or in this simulation, we can see three lines. The red line shows the AGSM model for 432 km 5 plus 2 antennas. The black dotted line shows the 432 km model for 5 plus 3 antennas, and the blue line shows the theoretical model, which clearly shows that the 5 cross 3 model having high spectral efficiency than 5 cross 2 antennas. Similarly, if we see the spectral efficiency of AGSM and SM MIMO, we can clearly see that the AGSM MIMO, which having the black line in the graph, is much better, is much high value than the GSM MIMO.